journalists that investigate some of the opposing viewpoints in some tyranny countries also needs to avoid the risk of being arrested for their professional curiosity, because journalists of recent are found to use to relay some uncensored stories from various places of the world. So such journalists need to, in order to communicate, to prevent themselves from being arrested for whatever reason. Activists in some danger zones of the world also uses Tor in order to communicate with other people outside the zone. Most especially, these people uses the Tor relay service, the Tor hidden service. I beg your pardon. The Tor hidden service, which is not part of the presentation today, helps in providing a service without revealing where the server is. In a nutshell, you can use Tor hidden service in your local machine without having the traditional IP addresses. You configure the server on your local machine, provided you are using Tor, and you distribute your username to whoever is interested in your services outside anywhere, and it can be able to reach you based on these hidden services arrangements. But unfortunately, this is not part of our discussion today. Maybe some other days we can discuss about that. Then the bloggers who are afraid of being fired on sue for their curiosity, for saying something online that is legally okay. They also post information on their site anonymously. Not only the activists, the bloggers, law enforcement also uses Tor to carry out surveillance on some questionable website in such a way that they cannot be detected. Okay? Honest, indeed criminal, but they already have it. They don't need this. They have their own way of doing their crime online. So the main target is the aforementioned and other users which we haven't mentioned here. Now let's see how Tor works. We will take a couple of minutes to demonstrate some details here. Here is the architectures of the Tor network. I adopt this from a paper written by Dr. Dua. He's in Waterloo, a postdoc in Waterloo. I adopted this from one of his paper. Okay, here we can see the client who wants to communicate with the host. The client on his system must have what we call onion proxy. Through the onion proxy, the client contact the onion proxies that he wants to communicate with an application server that is being served by the server, the host. So in that case, the directory server, the onion proxies contact the directory server to fetch a list of the Tor relays with their status, and their status such as the bandwidth and what they can do, how they can help. Because the Tor relays are of different types. We have, as you can see, the exit router, the exit nodes, the entry guard, and the middle node. Mostly, in main cases for performance issues and security, Tor recommend the use of 3 relays between the user and the server. So what happens is The exit router normally has some policy because it's been contributed by individuals, and individual will decide, okay, I will contribute a node as exit router, but I can only transmit HTTP connection, meaning through port 80 only. Or another donor may say he will use its only port 21 for transmission, which is the FTP file protocol that it can support. So these are put into consideration in choosing by the owner proxy in choosing what exit nodes should be used in order to get the services provided by the server. And other consideration is the bandwidth that can be supported by individuals, because the Tor community cannot enforce someone to give what it cannot offer. So you have the right to give as small as possible or as big as much as possible. Though there are some control in these days because of some people may likely use this opportunity to act maliciously online, which is one of the things we are investigating as a researcher. Okay, so here the entry guard also is chosen based on some certain usable properties such as the stability, because most of these relays, one of the things is that since they are not being controlled, is at which individuals gives out their system and donate it to be used as a relay. At any point in time, an individual may likely go offline, so the directory servers maintains the status of this relay, and based on some criteria, it gives some major information about each of the nodes, such as the either is stable or unstable, things like that, the bandwidth, and the what it's to be supported, either to use as a relay node, a guard node, or just an exit node or whatever. Okay, so now let's see the basic idea on how this works. In our public network, when Alice wants to communicate with Bob, all she does is to establish TCP connection. So in this case, when Alice contacts Bob, the IP address of Alice is known to Bob. Likewise, when Bob is contacting Alice, the IP address of Bob is known to Alice. And this can be used for traffic analysis. These information, it can be used to know where is Alice staying, where is Alice routing from, and things like that, stuff like that. Okay, now in our anonymous network like Tor, when Alice wants to communicate with Bob, it does so by first choosing some relay nodes or router, which are anonymous router. Through that relay, it passes its traffic to Bob. Okay, so this is what happened in the course of the anonymous network like Tor. In this case, Bob only knows that he's communicating with this last nodes and will not know that the real traffic is coming from Alice. Likewise, even this last node doesn't know about Alice, because all it knows that it's communicating with the middle nodes, while the middle nodes also know that it's communicating with the first node, which is the guard node. However, The guard know that Alice is communicating with it, but it doesn't know where the information will end. Where is it going to? So this is a typical idea of what the anonymity is all about. Based on this, the IP address of Alice automatically is hidden to Bob. Likewise, if Bob is also using the same Tor,